Hi, I'm Jay Myers, the CEO of Next Generation Manufacturing Canada, and welcome to another of our project podcasts. Today, I'm joined by Dan Desjardins. Dan is the CEO of Distributive, who has been working on a project with Honey Vision to develop a pretty unique solution for all of those companies that are looking at implementing digital solutions in manufacturing. And before we get into the project, Dan, give us a bit of an idea about your background and how you got into this gig in the first place.
Jayson, thank you very much, and it's a pleasure to be on with you and the NGen folks. So my name is Dan, background in computational physics, actually. And I was one of those researchers amongst many that needed a lot of compute power to do a lot of modeling and numerical simulation and advance some of the research that I was doing. And computing at scale was something I just never could get my hands on. And when you look at a lot of the technologies and the buzzwords that we hear in smart manufacturing on digital twins and so on and so forth, a lot of this takes a lot of compute power. So I had a lot of the similar problems that SMEs have nowadays, which is how do you get compute at scale that's affordable, secure, confidential in order to deliver business value. So my background in computational physics has made me very familiar with the pain of sourcing compute power to achieve my objectives. And that's exactly what was at the focus of our NGen feasibility project here with you.
Well, that's great. So clearly, you know some of the challenges that, and it's not only small companies are facing here, but as everybody talks about Industry 4.0, and many companies are interested in developing, adopting new digital solutions for their business. What are some of the challenges that you encountered, but also you see smaller companies in particular maybe facing here as they look to deploy digital technologies in their business?
Right. There are several barriers to adoption of smart manufacturing technologies right now. A lot of them have to do with money costs. A lot of them have to do with unclear ROI. So it's very difficult for decision makers to want to make those large bets to implement smart manufacturing approaches when they see the upfront sticker shock of what it would cost to implement something like this, and when it's not exactly clear what value they would derive on the other side of the implementation. And so what we did specifically within the feasibility study was to deploy a use case, one of many that are used in smart manufacturing, machine vision in support of XYZ. And what we weren't trying to show was that you could do machine vision, because that's been done many, many times. What we wanted to do is show that you could do it for 12 times less expensive than current approaches, which tend to be commercial cloud or expensive on-prem supercomputer infrastructure, what have you. And so what we set out to do is, yes, show a use case, a specific use case for a specific commercial partner, show the reduction in cost and the ease of implementation, but more importantly, show a low cost and low risk avenue to explore ROI. Is we think that the key or one of the keys to smart manufacturer process adoption is to provide low cost, low risk avenues to explore what that ROI is, so that decision makers can become comfortable with, what do I get when I implement these three things? All right. And if it doesn't cost $100 million to deploy and they get to experience that ROI, then it will ease the way for greater and more adoption, and this the trickle down benefit to smaller SMEs will reverberate across the Canadian ecosystem and abroad.
As you say, you're speaking about ROI and the value here of tech adoption. I'm reminded, and we were discussing just prior to jumping on this podcast, about some of the difficulties that companies face in even defining what their business objectives are. Here, that companies will invest in a technology, but not so much with a clear vision about why they're doing that, and without those clear business objectives, sometimes the tech adoption kind of goes awry for some reason here, but lots of costs get sunk in it, and seem to be a continuing money pit. Frankly, if not done correctly, what's your experience, and whether with this project or just generally in your background, Dan? Uh, how important is it for companies to have a well-defined business objective and to use the technology as a tool to achieving those business objectives rather than just jumping into technology itself?
I have a sort of two takes on that. It's innovation. Some of the biggest gains from innovation come from experimentation, right? So sometimes having a clear-cut goal in the beginning can hamper some of the most exciting possible use cases. Now, there should always be a plan, of course, but surprises can come from trying new technologies. Of course, that becomes impossible when it's extremely expensive. So we were lucky through this feasibility project. While conducting it, we were able to commercialize it right out of the gates with an SME. And they, like many that we've encountered in industry, are very much aware of smart this, smart that, efficiency gain here, decreased cost there, all the buzzwords in the smart manufacturing world. And they want to be smart too. They want to engage. They know there's value there, or at least they've been led to believe there's value there. Now they want to try it. So they'll try and imagine a couple of use cases. If they're a good SME, they've been operating for many years. And things are working. And so the idea of coming in and saying, okay, let's throw AI into this part, or it's almost like an afterthought. And will it actually yield value beyond just like the face value of saying that they're smart and they're evolving?
Right.
And so this is precisely so that the problems we've noticed, or that the challenge is that they're all excited. All decision makers are excited to implement some form of smart manufacturing to gain efficiencies, decrease costs, increase quality. But if it's not clear from the outset what that could be, then there's a greater hesitancy to pull out the wallets and spend a lot of money. And one of the biggest costs is cloud infrastructure. The amount of data processing required in order to do any bit of predictive analytics. I'll use a use case. Right now, we've been talking very much in the abstract, so maybe it'd be beneficial if I delve a little bit deeper.
Sure.
Let's use, for example, tier one automotive manufacturers. Some of the largest will lose about $500 million a year worth of rejected parts as they're going along the various stages of the assembly line. Wouldn't it be great if they could predict by stage 4 that a component would fail their acceptance test 40 stages later and kick it off sooner for retooling? Well, processing all the sensor data and running these sophisticated compute models and predictive analytics on all that data to find the combinations of situations and inputs, sensor input that would cause that rejection at the end, would cost an absolute arm and a leg to implement in real time, streaming all of that data to some cloud somewhere 2,000 miles away, do all that compute and then send back the answer. It would still be worth it, because if you could save even half of the wasted time of these wasted components, then we're talking about hundreds of millions of dollars. But if it costs you $100 million to implement, then it's a big upfront cost when it's not very sure that will be the outcome. So what we've done in a situation that's similar to this, but with machine vision, is we've deployed a compute network overlay on all the existing computers in the facility itself. And the existing devices that were there did all the compute and processing for their specific use case. So instead of costing about $160,000 a year, it cost $12,000 a year to give the same benefits, the same outputs of the computations, and data never left the building. And so by slashing costs by about 12x, we're looking to bring to SMEs everywhere, again, a lower cost path to exploring the ROI for implementing some of these data-driven approaches to gain efficiencies, increase quality, and decrease costs.
So you've been mentioning the application of this, particularly with machine vision and with honey vision. Here, what are some of the other applications that that this your solution could support?
Well, fundamentally, as a compute platform, it will process just it can be harnessed to be useful for just about anything. So in my case, it was computational physics, looking at electrodynamics and simulations and what have you. In this manufacturing setting, it was machine vision, but it can also be used to run predictive analytics to say, given these combinations of inputs from sensors, what is the likely output at the other side? In hospital settings, we've been optimizing surgical schedules. So if there's some modeling, some advanced research computing, some data science, some AI, some predictive analytics that needs some compute power, this type of platform is useful for each of those use cases. So at the end of the day, we centered on machine vision, but we want to make sure that the NGen community and others are aware that this is a compute layer for just about any other sophisticated compute application. And one by one, we're going to be reaching out, connecting with, and enabling some of these more interesting use cases.
So if you're taking 15 or 16 times the cost out of, or reducing cost by about 92% or something along those lines in terms of the cost of accessing the cloud, you're also opening this up not just for applications in manufacturing, but you're also opening it up, going back to where you came from, to experimentation and to do innovation as well on this and the application of new digital systems here as well. So that's an exciting part of what you're offering as well.
I couldn't agree more. Our backgrounds were our go-to-market in the background was to go through academia. There's a screaming need for compute resources across researchers in Canada, but also the world. Innovation depends on access to compute power. We're working with many scientific researchers, part of the Square Kilometre Array. That's a key part of Canada's astrophysics research efforts over the coming decade or decades. And the volume of data that these new space telescopes will produce is not even handleable by existing infrastructure. So the ability to study and probe the universe and extract answers depends directly on access to compute. And right now it's expensive. And just to put some numbers to it, procuring 1,000 vCPUs from your typical cloud provider costs $37,000 US a month. And when we go into these localities, like the universities, hospitals, or manufacturing facilities, every quad core desktop we deploy a screensaver on that goes and harnesses 4 to 8 vCPUs. So 250 computers running a screensaver generates about that much in compute value. So if you have 1,000 desktops, which is pretty small for any given university, hospital, or manufacturing facility, that's $2 million in compute value a year. That's harnessed out of infrastructure that's already there. And this can then be put to use, whether it's exploring why galaxies form the way they do, or more in the smart manufacturing context, looking for forklifts that are speeding around too close to the aircraft, or if safety equipment wasn't positioned in the right way, or if pallets are below a certain percentage, or what have you. There's infinite reasons to use compute to even designing the next golf club head, right, to maximize aerodynamic flow and what have you. That's all done by computers. Discovering the next drugs. Everything is compute bound, and if we can decrease that cost by 92%, which we've proven now, we're opening the floodgates for innovation across all sectors.
Exactly. So, what about the skills then that go into this? Is this also? Is the solution one that requires a great deal of additional training? Is it easy to implement?
So I like to go back to my starting discussion. So as a physicist, I spent 8 years getting good at math and physics itself. And when they said, now you have to code your solutions, I wrote some code. It wasn't very efficient, but it was able to run to completion on my laptop. It would take several days. And then when I wanted to go faster, because I wanted to do bigger, more important models, they said, well, now you have to learn how to program a supercomputer or go to the cloud and spend, X tens of thousands of dollars. So that's why I was like, you know what, I'm done. I did enough school to do physics. I don't want to learn how to manage a supercomputer, a data center. So we kept the team was gracious enough to keep I wouldn't say illiterate, but programming inefficient physicists like me in mind when they designed the tool set that gives access to this compute power. And so we've taken great care into making the API that uses and consumes and deploys these jobs to all these computers doable within about 5 lines of code. And in a different podcast, we could actually do a live demonstration. But we've made it extremely easy, 5 lines worth. We've made it extremely cost effective, 92% less the expense of cloud. And we keep data private and on-prem behind the firewall on computers that are already there. So this can be deployed anywhere, not just in Canada, but also overseas, giving access to, for example, we're working with some universities in Kenya right now to unlock all of the compute potential there in order to create compute clusters and create opportunities that can be harnessed to develop next-gen solutions there to tackle local issues and global issues.
So great potential for this. And as you can tell, I need all the training myself to figure out when I should mute my microphone and or not here too. So my apologies for things going off. You partnered with a great company here on the project around machine vision. How important was that collaboration, not just for the project, but for you? And what did you learn as a result of the collaboration?
The collaboration with HoneyVision was crucial. HoneyVision specializes in machine vision models, which is just outside of the scope of our expertise. So if you look at this at a bit of a pyramid, we're at the compute platform layer. The technical capability of aggregating compute power from machines everywhere in a building, that's where we thrive. Building the tool chains that then provide access to that compute power and the compute API, that's the point beyond which HoneyVision took over. So they developed a specific machine vision model that answered a specific need for our commercial customer in this project. In this case, it had to do with detecting the correct positioning of safety barriers around dangerous machinery. Again, as much as we find this interesting, this is not something that Distributive takes after. So HoneyVision built the models that responded to the end customer's business requirement and made sure that it got built and deployed on our platform, packaged it up together, and then deployed it on-prem into this customer's locale. They can go then and repeat this with 1,000 of their other customers. Every time they do that, they deploy Distributive's compute platform and their machine vision technology. But here's the advantage. By not parking their solution on Azure or AWS or Google, their compute costs are down by 92%. So HoneyVision can deploy this and completely beat the competition from an economics point of view, and they can pass a lot of those savings on to their customers. So everybody wins in this scenario. Data stays private and behind the firewall. Compute is 92% cheaper. HoneyVision can outcompete its competitors in the machine vision space because they have something that's way more affordable and way more secure, private, and confidential. We don't have time to go sell the specific machine vision solution to their 1,000 customers, but HoneyVision does. So if we can repeat this across a number of different use cases and across a couple different verticals, then we're fulfilling our objective, which is to be the cost-effective compute middle layer for several verticals out there, and allowing HoneyVision and a whole bunch of other solution providers to thrive and grow and provide solutions to their end customers, the smart manufacturers, the SMEs, in a low-cost way, low-risk way to explore the ROI of all things smart.
So you're mentioning the future in commercializing the solution, other types of use cases. Dan, what from your perspective and Distributives, what do you need to scale up here going forward?
We're constantly pulling bright talent to Kingston, Ontario. We're a bit of an anomaly here in Eastern Ontario in terms of a high deep tech company. So pulling more talent, raising more capital, getting the backing of both federal and provincial institutions, because this type of technology, it's on par with infrastructure level projects. Unlocking compute across the nation to achieve innovation objectives across robotics, genomics, precision medicine, manufacturing, advanced research computing, you name it. This is something that has the potential to impact the entire nation. If we look at Canada's National Digital Charter, every single one of their objectives requires a tremendous amount of compute to go forward and be successful. So we're sitting on this universal solution for access to compute, and so we need to keep our momentum up and showing the world that we can slash prices by 92%, as we just did with machine vision. We have a giant computational application running at Laurier University right now. We just passed through 5 quadrillion computations for a mathematics research project. We're looking to roll this out to university, college campuses across the country. We're deploying in hospitals, right? So reducing the need for cloud in there to do some pretty sophisticated resource allocation optimization. Next is getting into genomics compute, taking advantage of small cohorts of very private sensitive data. Instead of bringing all that data to the cloud, which you can't do because it's sensitive, very, very sensitive data, you push compute to the edge. And you do the compute there so data never leaves the firewall, and you do it cost effectively. This is the way to fast, effective progress. And more importantly, by making it simple and accessible, 5 lines of code or less, you allow anybody, like from the dumb physicist like me to the advanced hardware and software engineers who are already working with digital infrastructure, to be able to tap into double, triple, quadruple the compute capacity that's out there today. So it's all about unlocking and unleashing innovation through easy, affordable, abundant access to compute.
So Dan, I can tell you, all the team at NGen look forward to working with you to help achieving that vision and to help on the commercialization side. So let me ask you to finish up a really self-serving question. It's difficult to get funding from NGen, particularly for a small-scale feasibility study. What's it been like working with us? And do you have any recommendations or suggestions for others who might be looking at NGen projects?
Well, for us personally, the process was smooth, well defined, and honestly, I don't have any complaints. We followed the steps. Everything was clear. We thought we made a good point on what we were trying to prove. NGen gracefully agreed, and then they gave us the green light for the project. We held up our end of the bargain. We delivered the results we wanted to show, and now we're hoping to continue the good work, scale up to an even bigger project, but perhaps more importantly, tap into NGen's great network, reach out and share the good news, share what hasn't been done, because it's not theoretical anymore. It's real, and we did that with NGen's help. And so might as well celebrate it and get it out there and make the dent that we're both excited to make. In my case, it's compute broadly. In yours, it's the application of smart technologies in NGen. So what a great overlap that we've demonstrated together, and now we go forward.
Absolutely. Listen, and as you say, look forward to working with you in the future, making that whole vision more of a reality than it already is. And you've come such a long way in a really short period of time too. Congratulations, Dan. And
Jayson, thank you very much, and I'll echo that thanks on to our entire team at Distributive, who are extremely talented, hardworking, and making this a reality. Thank you.
Absolutely. Thanks for joining me today.
Bye-bye.